Hey everyone, and welcome back to another video. In this one, you're going to learn object-oriented programming concepts using Squid Game. If you have not subscribed to the channel yet, do it as it really helps push the content out, and also like the video at the end if you found this useful. So now, without further ado, let's get started. Now, the first thing that we are going to discuss is something called polymorphism. And this is a concept in which a simple thing or a single thing essentially behaves differently in different contexts. For example, in Squid Game, this old man Ilman is essentially the creator of the game, he's also a player in the game, and also the host that we have seen in different parts of the series. Now, you see that it's the same person but behaving differently in different characteristics. In one case, he is managing or creating the game. In another one, he's playing and completing all of the tasks, doing the tug of war and also the red light, green light. And then as a host, he's entertaining the other hosts or the VIPs. So the entity or the person is same, but the functionality is different. Now let's see how this would look in terms of code. So we are going to have a look at this example where we have a class of user, and this is really simple. So this user has one property called email and then a function called login. Now this user is being created here as a test employee. So let's say this is called test employee, which is a user, and then we have an email that we are providing. Now once this is provided, it goes into the constructor and then takes this email and assigns this to this property, right? Now finally, if I just do a console.log of test employee, let's see what happens. So I'm going to just run this. And in the meantime, note that when we call the login function, we are passing this password as the string here. It goes inside and then it just logs this one. So now you see that we get login done, which is using this particular statement. And then when we log this user, you see that the email has been set to test@test.com, which is in the constructor. Now, how do we perform polymorphism in this case? So let's suppose we have an extended version of this user, which would be something like admin. So let's say we have an admin here, and then we have the admin extending. So we are going to say extends user. And then inside here, we are going to have a constructor just to override one thing. So in this constructor, we are going to essentially do the same thing as this one. So we are going to essentially copy this one, paste it. And now instead of doing this, we can simply say super dot, or actually super, and then we can pass the email. Now, when we extend a class, we need to use this super when we are using a constructor. So if you use a constructor, it's going to have the same signature, but then we call super as well. Now, apart from using super, we are also going to have, let's say, a function here that is called notify admin. Let's say the application has this security check-in that whenever the admin logs in, we send an email to the admin that you have been logged in. So we would do something like console.log sending mail, and then here we can have another string, and then we can call it something like someone logged into your account. And let's say we also log the email itself. So we say this.email. So this is going to be the console log that is going to present when an admin logs in. So here we can call this.notify whenever an admin is logged in. So here we are going to essentially override this login method with password. So we're not doing this into the constructor, but rather when the user logs in. So this is going to be of type string. And here we essentially just notify the admin and we console.log here admin logged in. Now see that this is extending the user, and let's say we also had an employee class. So we would say class employee extends admin, and inside here we are not going to have any constructor. Actually, we're not going to have any constructor here as well because we are not doing anything special here. So I'm just going to remove this. So we have notify admin and then login here. Now inside here we also have a login as an employee. This employee would also log in via a password, and this is going to be a string. Now, all we need to do is to log in the particular user, and let's suppose the actual logic of login is here in the super class or in the base class. So actual login logic here. Now, once we do this, that means that once we log in via admin, we also need to just do a super.login. So we do it with the password, which executes the actual logic of the login itself and also notifies the admin. Similarly, when we log in via employee, this would also call super.login with the password. And here we also need to do something special. Now, I don't want any employee to be logged in unless that employee has been approved. So let's say we maintain an array of approved employees at the top of this class. So let's say we have const approved employees, and here we have an array that has test@test.com. And now when we log in using this user or this email, then it should be logged in, otherwise not. So when the employee logins, we should do something like if this or if approved employees dot includes, and here we say this dot email, then we are good. But if that's not the case, then we just return, and then we also do a console.log here that says employee, and we can essentially use the string interpolation here saying this dot email has not been approved, cannot log in. So if that's the case, then we don't log in, otherwise we just log in, and then we also say console.log and employee logged in. And now you can have multiple logic here, whatever you want to do here. So if I do this, and if I try to now create an employee instead of the user, let's see what happens. And I'm going to change the email here a bit. So let's say we are trying to use an email that is not approved. So if I run this, let's see what happens. So you see here that we got the output employee test22@test.com has not been approved, cannot log in, as you can see here. And we also show the email of the employee as well. Now, if I change this to the approved email, which is test@test.com, which is here, let's see what happens then. And there you go. You can see that we got this email called employee logged in. Interesting. I see that I made a mistake, which is I'm extending from admin, whereas this should have been user. So I'm going to save this and run this again, and let's see what happens then. There you go. You can see that it says login done, which is essentially from the super login from here. Then it says employee logged in from here, and we can see the employee as well. Now, since this user's email was one of the approved emails, that's why we got login, otherwise not. Now the question is, where is polymorphism in this whole scenario? And the answer is this login method, because this login method does different things in terms of different situations. However, you can see that here this login is from the base class, but whenever we create an employee or an admin, we essentially override the base class's method and then we do something different. This is called polymorphism, where we have the same function, but it's behaving differently in different scenarios. For employee, it does a different thing. For admin, it does a different thing, although they all are coming from the same class or the same base class. Now, another way of polymorphism is method overloading. And that is when a particular method essentially has multiple optional inputs as well. For example, if this employee also had something like this, like approved as a boolean, but we also have this as an optional, then this method, this login method, is again polymorphic because I can call this just like this. So here I'm going to say const test2employee, and here I would say something like new employee, and here I can give this new Gmail, so test22@gmail.com, and then here I can also say this, and then I can say test employee or test2employee, which doesn't exist because we have a typo. So if I do this and then I say login and I say test123 as password and then I say approve true. So if I do this, then let's see what happens. So in this case, it should still allow me to log in with this test2employee. So if I do console.log test2employee, that should also log in. So if I just run this, let's see what happens. Awesome. So now you can see that the first user was logged in and the second user was also logged in because of this approved optional parameter, which made this login essentially having two things. One is this is doing method overriding, which means that it is overriding its base class's method. But this function also has optional parameters as well, which makes it method overloading. So I hope this makes sense. Now let's talk about the second concept, which is inheritance. Inheritance is a concept in object-oriented programming in which we inherit a lot of properties and methods from the base class in all the child class or the derived class, which means that all of the child class and the instances of those child classes would have the same functions as the base class or would inherit all of those properties. Let me show you an example from the Squid Game now. So in the Squid Game, this character or this whole dress code is essentially the player itself. So you could say that this player is the base class, which has a dress code, which has the same tasks or the same game to play, the same food for all the players. So it has same characteristics. They live at the same place. They are in the same place. When they move into the arena, they go at the same time. But this player has multiple instances, which means there are multiple players in the game. For example, the 456, the 101, 067, each player is an instance of the player class, but each player also has their own attributes. For example, one of them is a woman, one of them is a villain, one of them is this guy. So you can see that they have different mindsets on how to play the game, but they all come from the base class, which is the player class. Now let's talk about how we see that in the code itself. So for the example of inheritance, we have this user class, which essentially has a gross salary, and that's about it. So if I wanted to create a new instance of this user class, I would just use the new keyword along with the gross salary, and there I have the user. Now let's suppose we are talking about a company where we have managers and employees. So we are going to create two classes. One is going to be manager, which extends user, and then another one is employee. So let's say employee, and then it extends user as well. Now let's assume that this manager has a salary, and we have a function called getSalary, and inside this what essentially has is that we just return this dot gross salary. We're talking about a company which has different rule sets for managers versus employees. So for managers, the salary is the entire gross salary, and we get that. But for employees, let's say we have a different situation where they have a base salary and a bonus as well. So in this case, we are going to override the constructor itself, and the constructor would then call super as well. Now you can see that there is a red line here because the constructor has to have the same signature as this one. So I'm going to just copy this, paste it here, and now I'm going to call the super with this gross salary. So now we are kind of done with the constructor thing. But then as I said, this user has a base salary. So we would have a base salary, which is going to be a number, and then a bonus, and then this is going to also be a number. So we could also call this salary bonus, which is going to be a number. Now we are going to assign this with something like this. So we are going to say this dot base salary. Let's suppose this company has a policy that the base salary is 80% of the salary, and then this bonus is essentially 20%. So that would make it something like this dot gross salary multiplied by 0.8, which essentially becomes the base salary. And then we do something like this dot salary bonus. Now I can just say this dot gross salary minus this dot base salary. So we are going to get the salary bonus in this case. Now the get salary method in this case would be a bit different, because now we have to know how was the performance of this employee so we can give the bonus accordingly. So that means we would have something like this, and we would say return this dot base salary. This is going to be always given to this employee, but then the bonus part comes in something like this. So we say this dot bonus or salary bonus, which is right now, let's say 20% of the salary. And in this case, we are going to say multiply by a factor, which is how good the employee performed in this particular month. So here that would be performance factor. And then let's say if this was something like 25%, 30%, whatever that was. So let's say this is a number, and whatever that number is, we are going to just take that number and then divide it by 100. And now we get the salary for this particular employee. Now let's test this out and see how this works. So I'm going to say something like const Ahsan equals new employee. And let's say we have the gross salary of this person as 10,000 units. That would make it 8,000 as the base salary, and the bonus would be 2000, right? Now, if I just do a console.log of Ahsan, let's see what we get out of it. So you see here that we get the gross salary as 10,000, base salary is 8,000, and salary bonus is 2000. Let's get the salary for this guy for the month, and it would be something like console.log Ahsan.get salary. You can see that I get the method here. And here, if I say that the performance of this guy would be 50% in this month, so I would say something like 50%. And that means that we are going to get the base salary, which is 8,000 for sure. But then the salary bonus would be 50% or half of it, which means that we are going to get a total of 9,000 as a salary. So here I can say something like salary for this month, and then that would be something like this. And then we get a comma, and then run it, and then try it out. Awesome. So you can see that we get the value 9,000 here, and I fixed the typo here as well. So this is how it works. Now you might be thinking, where is inheritance in all of this? And the inheritance is essentially in extending the class. You can see that these classes, the manager and the employee, they did not have to implement the gross salary class because it already is implemented in this user class. Now, I could also have the login method here, and that would mean that this manager now gets the login method and the employee also gets the login method. So if I just do something like console.log and if I say that user logged in, I can essentially call this method right from the employee as well as from a manager that I would create. So I can simply do Ahsan here, and if I say dot, you see that we have all these functions including the login function. This login method is essentially coming from the user class, the base class, and the other properties as well. You can see that here in the employee we have the base salary, salary bonus, but not the gross salary. Gross salary is a part of the user class, but if I just do Ahsan dot, you can also see the gross salary coming here, right? So this is essentially inheritance, and this is really useful when you have to have multiple kind of classes which essentially have the same properties. So you can have a base class and then extend other classes out of it. So I hope this makes sense. Now let's talk about the third thing, which is abstraction. Now, abstraction is a concept in which we hide the complex implementation and just provide the user the simpler version of it. So the user doesn't have to worry about how things work, but just has to know which functions to call or which properties to access, for example. Now, how does this apply in Squid Game? Let's check it out. So in the Squid Game, this player only gets to see the result of the process, which means that the user gets this candy with multiple shapes, but they don't have to know about the details of how this candy was made. That is the entire process. So the sugar game implementation behind the screen, where they were pouring a lot of liquids and adding a lot of sugars, the user or the player doesn't have to worry about it. They just have to know that this is the game, this is the candy, and now I have to work with that. They do not need to know about the actual implementation. So for abstraction, we are going to look into a similar example where we have a front-end engineer and we need to calculate the front-end engineer's salary in this case, including the bonus as well. So let's suppose we had multiple kind of engineers and they would also have this same logic or this same function, and we don't need to let them know how to calculate the bonus, which means that this class front-end engineer should not have that logic. The front-end engineer should not be worried about how the salary is calculated, but the software engineer class or the base class can have that. So first I'm going to create a class here. We're going to call this software engineer.ts, and inside here we're going to paste some code. So I'm going to just copy some code and then paste it here. And now you see what this is. This is a class which has a gross salary, a bonus factor, and a constructor. So whenever we create a new instance of software engineer, we provide the gross salary and the bonus factor, and then these are assigned to this property. And then we have a function called calculate bonus, which means that it's going to take the gross salary, multiply the bonus factor, and then just return the value out of it. Now we can go ahead and just extend this class, but first we need to import. So we can say software engineer from, and here we can say software engineer. So we are importing the class, and then we are extending this class. So we say extend software engineer. Now here you see that we don't need to implement the calculate bonus class. All we need to do is create a software engineer or a front-end engineer. So we can say something like const Ahsan equals new front-end engineer. So we can say front-end engineer. And here you can see that it already provides us the value of gross salary or the options to provide gross salary and bonus factor. So here let's say the salary is 10,000 units, so 10,000. And here we have a bonus factor. Let's say we decided that this front-end engineer is going to have a 30% bonus factor. So we are going to say 30 here. Now, if I go ahead and say console.log Ahsan, then we're going to see that front-end engineer as well. But if I also do console.log Ahsan dot, and now here you can see that we should also be able to access that property, which is calculate bonus, right? And if I call this, this should essentially show us the value out of it. So now I'm gonna just run this and let's see what the output is. Now you can see that here we got 30,000, which essentially is not correct, as I should have passed 0.3 as the bonus factor, which would essentially give us the 30% of this base salary and give us the correct output. Now, as a front-end engineer, I could have multiple things here. I could say something like Ahsan dot, and here I can say favorite, which is favorite frameworks array. So I can say frameworks.push here, actually something like this. So we can say the first one is Angular, and then I also, let's say, like a Flutter and React. So if I do this, that would mean that this class essentially has the Ahsan working with this property, which is the front-end engineer thing. It's not something that is related to the salary, which is a core function of a software engineer. That's why we have abstracted it out to the upper class, So the front-end engineer doesn't have to worry about calculating the bonus. The front-end engineer can think about their favorite frameworks and also other functionality, but the calculate bonus is already there. Now this seems like it's kind of related to inheritance because we are inheriting the calculate bonus function, but we are also abstracting this logic out. Otherwise, we could have the same implementation here just like this, right? And this wouldn't hurt us. But the thing is that if we do this, then we would have to create another class for front-end engineer, and then there would be something like a back-end engineer, something like this, right? Which wouldn't have favorite frameworks, but now this is kind of the same exact thing. So we don't want that. We want to abstract the logic out and kind of make sure that we have this particular implementation hidden from the front-end engineer class. Now I hope this makes sense. Now let's talk about the final concept, which is encapsulation. And this is a concept in which we encapsulate all of the related logic into one class, which means that everything that has to work together is going to be placed within a class. And it also kind of works as a security layer in which if we don't want to expose something outside of a class, we kind of make it private or protected or something like that, which means that no one should be able to modify this particular encapsulated logic that we want to hide from someone. So let's see how this works in Squid Game. So in the world of a Squid Game, this is really easy. This whole Squid Game is an encapsulation because everything is encapsulated within one place, which is this whole arena, the building. The players are encapsulated, the tasks are encapsulated, the money is there, the whole hosts are there, the VIPs are there, everything is encapsulated within one place, whereas the outside world doesn't even know about this. So they have protected everything, kept them inside, and this is how encapsulation works. Now, how does this work in terms of coding? Let's check it out. So we are going to have the same example in which we have the software engineer class, we have a front-end engineer here, and now we have a different class for software engineer. Now here, instead of what we had in abstraction, you see that in abstraction, we had this calculate bonus function, right? So for example, in abstraction, I can actually go here and say something like Ahsan dot calculate bonus, which is exactly this class. So I'm just going to copy this. So here I could say calculate bonus equals function, and this function is essentially going to return this dot, and I can get the property value from here, which is gross salary, and this. And here I can also use toFixed because that is what we returned as a string. And now I have kind of hacked this class, so I get 100% of the bonus every time. So now even if the factor was 30% as the bonus, I still get 10,000, which is I get 100% bonus of my salary. Now the encapsulation essentially makes sure that we don't do that. So what we are doing here is that we have this calculate bonus function, which essentially has this gross salary, right? And then we have this bonus factor toFixed. Now in this case, what we have is we have this calculate bonus, but we also get this bonus factor here, which is used here toFixed. Now notice this example that I gave is not perhaps the best example because even with encapsulation, we can override functions, and there's a proposal in TypeScript that essentially kind of would prevent this from happening. But right now, even with encapsulation, I can override this. But the point is, if this calculate bonus was a function that this front-end engineer is not going to use, but only the admins, then this front-end engineer or whoever is creating this class would not even know about this calculate bonus unless they do something like this. So Ahsan dot calculate bonus, right? Now, if that's the case here, what would happen is if I go to encapsulation, here we have this private modifier which hides the logic of this bonus factor. Now we are making sure that this bonus factor is not something that is provided, but is always going to be calculated within this logic. So here you see that we have a bit difference. When we create a front-end engineer with this abstraction class, we provide the gross salary and the bonus. But here, since we have a different constructor, we don't need to provide the bonus factor because we are selecting a random one right now because of some reason. So in this case, when we create a new front-end engineer, we are going to say const Ahsan equals new front-end engineer. And here I just need to provide the units for the gross salary. And then I can say something like Ahsan or console.log Ahsan dot, and here I can say something like calculate bonus. And when I do this, after this, I can simply say console.log Ahsan. And now let's run this and see what happens. Awesome, let's go. You can see that we have 5,000 as the bonus decided for Ahsan for this month. And we also see that we have the gross salary and the favorite frameworks because of this class and the base class as well. Now here, if I try to do something like Ahsan dot, let's see what happens. You can see that we get the calculate bonus class, the favorite frameworks, the gross salary, but we are not able to see this bonus factor getter. This could be a function. This is a getter right now. So you can see that we are hiding the logic within the class and not exposing this to the outside world. So no one gets access to it and no one overrides this as well. Awesome. There you go. I explained the object-oriented programming concepts to you using Squid Game, and I'm not the first to do this. If you find this, you can find some older posts from some people using images as well. But if you like this video, make sure to give this a thumbs up. Also, subscribe to the channel if you have not already, and I'm gonna see you in the next video. Happy coding.